Hi guys, welcome to the linear regression project solution lecture. I hope you have already done with all the tasks without the help of solution lecture. Let's go through these tasks one by one and find out the solutions together. Once again, we are going to use linear regression model to predict the insurance cost for the company. So the first thing first, import the required libraries. Let's run this cell so that we import all the required libraries. So the next is, please load the dataset into a pandas data frame and output the head of the data. So df equal to pd dot read csv and the file name is insurance. You can always press tab for autocomplete, and then we are supposed to display the head df dot head. So we are reading the file and displaying the head of the data frame in the same cell. Let's run this cell. And here we have the head of our data frame. So moving forward, notice the smoker column is yes or no. So this column is yes or no. Create a new column where you will have 1 for yes and 0 for no. Hint is, you need to write a function for this task. Recall your skills in Python Essentials and create a function here. To create a function, we start with a keyword def. And let's call the function map smoking because we are mapping the smoker column here. And pass in column here. Then initialize an empty list here. Mapped equal to empty list. And when we grab a column, we need to go through all the values yes or no's in the column one by one. So for value in column, if value is yes, so what we want if it is yes, we want 1. Mapped dot append 1. If you don't find yes, then else mapped dot append 0. And at the end, return mapped. Let's run this cell so our function is working. Let's add new cell here and new call equal to call the function map smoking and pass in df smoker. What we are doing, we are calling the function map underscore smoking, passing the column smoker to that function, and at the end we are going to get a new column that we can use to add new column in our data frame. Let's display this new call as well and run this cell. So here we have. So we have zeros and 1 in new underscore call. Let's add a new cell and then add this new call to our data frame. So df, name the new column smoker underscore norm equal to new call, and let's run this cell. It should be df here, and let's display the head of data frame as well just to check, and run this cell, and here we have new column to our data frame. This was not required, but just to check that we have added a new column to our data frame. We can do all these tasks in a single line after the function as well. Like if we say df smoker norm equal to and call the function map smoking and pass in df smoker and run this cell, it will display the same output. But we are not going to run this cell here because we are already done with the new column. So instead of splitting the tasks, you can do everything in a single cell. So moving forward, could you please write a function that return 1 for BMI greater than 30 and 0 for all other BMI values? Let's copy the function from this cell. And this time we are going to do everything in a single cell. So let's paste it here, and instead of map smoking, we are mapping BMI column and say we want obese. And if the value is greater than 30, append 1, else append 0. And our new column here is obese. And which column we are supposed to grab? BMI. So once again, what we are going to do, we are defining a function map obese, grabbing a column which is BMI and mapping the values in that column. If value is greater than 30, we are appending 1 to this mapped, which is an empty list. And if it is not greater than 30, we are appending 0 and returning the mapped. And here we are calling the map underscore obese and passing the column and then adding the column to our data frame at the same time. Let's run this cell. So there's no error, it's working properly. Let's check the head of our data frame again. Run this cell, and here we have another column obese. Moving forward, notice the sex column in male and female. Once again, let's copy this function here, and this is similar to the smoker column actually. And now we are mapping sex. And if you will have 1 for male and 0 for female. So for value in column, if value is equal to female, append 0, else append 1. So if value is female, we are putting 0, and if it is not female, we are putting 1, and the new column is sex norm. And which function we are calling? The new one, which is map underscore sex, and passing the column sex. Let's run this cell. There's no error, so the function is working properly. And check the head of our data frame, df.head, just to see if we have all the columns now. And here we have all the new columns in your data frame, df. You have a couple of new columns in your data. Check the head of your data frame. This is what we have already done here. So you just need to display the head again. Moving forward, how many observations you have in your data. Also display the basic statistics of your data frame. Hint is info and describe. You need to call info and describe on your data frame. So df.info, run this cell, and here you have 1338 entries. You have columns age, sex, BMI, and these are the new columns: sex, norm, smoker norm, and obese. So the next one is statistics. You need to call describe on your data frame, df.describe, and let's run this cell. Here you have the basic statistics on our data frame: count, mean, standard deviation, for each column minimum 25%, and so on. So moving forward, please output the list of columns in your data frame. It should be very simple again. You just need to call columns on your data frame. So df dot, you can always press tab for autocomplete and run this cell. Here we have a list of all the columns in our data frame. So the next section is exploratory data analysis. He's asking for to recreate these plots. If you notice, the first on your left side is a count plot, where on your right side is a mean along y-axis, which is also hint here, and you can use a bar plot. We can use matplotlib's subplots here, and we know the syntax is fig axis equal to plt dot subplots, pass in n rows, we want one row, and pass in n calls, we have 1 and 2 columns, and fig size 12 4, and then we can call sns dot count plot and pass in sex, which is along x in both of these charts. So x equal to sex, our data is df, and here we see that he is splitting smoker yes or no. So another parameter he is passing, which is hue, for categorical variable smoker here. So hue equal to smoker, and then our axis is, this one is axis 0 and this one is axis 1. So axis 0. So the next second plot is bar plot, sns dot bar plot, pass in x equal to sex here again, and y equal to, we need to pass in y for bar plot as well. So mean charges, the column we need to grab is charges here, and by default we get mean along y-axis for bar plot. Our data is df, and once again hue argument is smoker here, smoker yes no, and where we need to put this plot, axis 0 and axis 1. So once again, fig axis plt subplots, a simple syntax in matplotlib. We have one row and 2 columns, and we are setting the figure size. Then we are calling cbonds count plot, passing the sex column, and in count plot we only pass one column. And what is our data frame? df. We are passing smoker as hue just for this split here, and grabbing the axis at 0 index. The next one is, we are calling bar plot from cbond, passing x as sex column, y is our charges, hue is once again smoker, and putting this chart on axis at 1 index. Let's run this cell. So we need to say ax equal to axis 1. Let's rerun this cell, and here we have the same plot. Let's make it slightly smaller so that it fits on the screen. Here we have the same output, count plot and a bar plot. Moving forward, please recreate the plot below. Once again, this is a count plot, and we are grabbing children column. We only need to pass in one column to the count plot. We can call cbonds count plot and pass in x equal to children, and our data frame is df. So let's run this cell. Here we have the same output. We have children along x-axis and count along y-axis, which is a number of observations. Most of the people have no children, and very few of them have 4 or 5 children. So moving forward, please recreate the plot below. Hint is kind equal to reg. So notice the joint grid here. You can call cbonds a joint plot here and pass in kind equal to reg. Let's call sns dot joint plot, pass in x, and what is x? BMI. BMI and y equal to charges, and our data is df, and we can pass in kind, which is a hint here, reg. So we're calling Seaborn's joint plot, passing x equal to BMI, y is charges, data is data frame df, and kind is reg. Let's run this cell, and here we have the same output. We have the charges along y-axis, we have BMI along x-axis, and this is our joint plot. So moving forward, recreate the heat map for correlations. This should be very simple again. SNS dot heat map. We need to call correlation function on our data frame df. So df dot core, and let's run this cell here. So we have a simple heat map. So the difference is we need to put these values, which are correlation values. So we can set anode equal to true and rerun this cell. And here we have the same output. So moving forward to the linear regression model training. Separate data into X and Y arrays. Use age, BMI, children, and let's copy this list here, and X equal to DF, and pass in this list. So we are grabbing age, BMI, children, smoker, norm, obese column from our data frame and passing it to X. And our Y is equal to charges, DF. Let's copy this one, charges. Notice the difference. If we are grabbing more than one column, we are passing the list. And if we are grabbing only single column, we are simply passing this to data frame in square brackets. Let's run this cell. There's no error, so we got X and Y. Import train test split and split the data into training and test data sets. So we know we can import train test split from Scikit-learn dot model selection. So from Scikit-learn dot model selection, you can always use tab to autocomplete. Import train and press tab to autocomplete. Let's run this cell. So we have imported train test split and then train test split. Press shift tab, and this is easier to save some time, and move down. Here we have X train X test. Let's copy this one and paste it here. Delete these dots. Size is 0.33 and random state is 101. So here we are splitting into X train X test, Y train Y test using train test split, and the test size is 33%, 0.33. Let's run this cell. So no error. We are done with this train test split. Let's check the head of X train now. So X underscore train dot head. If we run this cell, here we have 612654253. Look at your output. You are getting the same output because you're passing the same numbers here. Size is 33% and random state is 101. If you pass different numbers, you will get different train test split. Let's check this one here. If we pass in 42 and rerun this cell and then check the head again, we're getting different stuff here. Once again, if you pass in 101 and rerun this cell, we are getting the same numbers. So if you pass in the same numbers here, you're going to get the same output. So the next one is import a linear model. Let's import linear model from Scikit-learn import linear model and run this cell. So create an instance for linear regression model. So LM is going to be our instance here. Linear model dot linear regression. Always press tab for autocomplete and run this cell. So LM is our instance for linear regression model. So moving forward, train your model on X train and Y train. Let's use that instance LM and call fit here. And then pass in the data X train and Y train. You can press tab and you see the options and you can select the one which is required. Let's run this cell and here we have our trained model. So moving forward, what is the value of the intercept? We can get the value of intercept using lm dot intercept, and if we run this cell, here we have the value of intercept here. So he's using print because we have out cell. There's no out cell. Let's put it into the print function. And here we have the same value now. What are the values of coefficients? We can call lm dot coef underscore and run this cell, and here we have the coefficients 241.39, 90.26 and so on. He's asking to create a data frame using columns from X as index and values of the coefficients in a new column coefficient. So let's recreate the output what he's asking for. So we can call pd dot data frame, pass in data which is lm dot coef, and our columns are from X. So X dot columns, and the name of columns is this one, coefficients. And let's pass into coef and run this cell. So there's no error, so it's working properly. Let's insert a new cell here and output coef. Here we have the same output: age, BMI, children, smoker, norm, and obese. So we got a data frame with coefficient marks with their respective column. So moving forward, our model have never seen X test. Let's provide test data X test to our created model and see what predictions are. So here we need to do the predictions. So pred equal to lm dot and call predict instead of fit and pass in the test data. And if we run this cell, there's no error, so it's working properly. Now generate the scatter plot below. So now we have predictions and we have the y-test. We need to plot y-test against predictions here. So this is a very simple scatter plot. plt dot scatter and pass in y-test and pred. Let's run this cell and here we have the same output. The difference is we need to put X label and Y label. Let's put the labels as well. plt dot X label, which is Y test, and plt dot Y label. Once again, just to remind you, tab for autocomplete. So this is predictions. Let's rerun this cell and here we have the same output. We have predictions along Y and we have Y test along X axis. So the next one is recreate the residual histogram, and the hint is Y test minus predictions. We can call Seaborn's dist plot here. So SNS, I hope you remember from the previous lecture because this was the same function we called in the previous lecture as well. Dist plot and pass in Y test minus pred and run this cell. and here we have the similar output, and it looks like the bin size is different. Look at this one and this one, we see the difference, and the bin size here is actually 30. Don't worry about the bin size here, because once you get this one, this is fine. Run this cell, and here we have the same output. So the last thing he's asking for, print MAE, MSE, and RMSE. To do this thing, we need to import matrices as well. So from Scikit-learn, import matrix. Let's run this cell and add a new cell, and then print MAE matrix dot mean absolute error, and if you press shift tab, pass in y true and y pred, so the y test and predictions. So y test and pred, and then close the parenthesis here, copy this one again, paste 2 times, and then second one is mean squared error. You can press tab for autocomplete, and the third one is actually mean squared error, and we need to get the square root for mean squared error using numpy np.sqrt and passing that to sqrt. So this one is MSE RMSE, and close this parenthesis, and everything is okay, it's good to go. Let's run this cell, and here we have the same output. If you move down to this notebook, you will see that there is an additional task. Calculate the insurance for the given BMI. BMI categories are defined as normal if it is 25, overweight if it is 35, and these are the upper limits. Only use age, BMI, and smoker coefficients in the function. So you need to calculate the expected insurance if the person comes with normal BMI, overweight, obese class 1, and so on. So the task is already solved here. So you need to create a function which is calculate insurance, pass in age, obesity, smoking, intercept, coefficients. So age coefficient, BMI coefficient, and smoker coefficient, and then return age coefficient multiplied by age, BMI coefficient multiplied by obesity, smoker coefficient multiplied by smoker, plus intercept. So this is a simple mathematics equation here to calculate the possible insurance for the customer with certain features. So you need to calculate the insurance for fixed age, and they all are smokers, and their BMI is different. So BMI is in this list, age is 50, smoker is yes. Initializing an empty list, calling a for loop, and grabbing this value from BMI one by one, and then we are calling this calculate insurance function and passing age value, which is actually BMI here, smoker, LM intercept, the value of intercept here, and the LM dot coefficients. We are getting this expected insurance. Notice that if the BMI is increasing from 25 to 60, the insurance is also increasing, like 23,000, 25, 28, 31, 33, 36, and 41. It is obvious that obesity is not a healthy thing. Obese you are, higher the insurance would be. So this was all about exercise solution lecture, guys. Go through these tasks once again and try to understand each and every step of these tasks. I hope you're enjoying the machine learning section. See you in the next lecture, where we are going to learn another very important machine learning algorithm, which is logistic regression. Good luck.